Hello children, let us start work, energy and power. First we will talk about kinetic energy. In our previous classes, we have studied about kinetic energy and the formula to calculate it. Suppose a particle having mass m is moving with velocity v. Then its kinetic energy is given by the formula k is equal to half mv square. Now we will talk about change in kinetic energy. Kinetic energy of a particle changes if its mass changes or its velocity changes or both of them change. Usually mass of a particle does not change, so its velocity should change. Change in velocity means either particle should accelerate or decelerate. This can happen in the presence of a force. So a force is necessary to change the kinetic energy of a particle. Let us talk about these 5 scenarios. In scenario 1, a particle is moving horizontally with velocity v. There is no force acting on it. That means its velocity will not change. So its kinetic energy will also remain the same. In scenario 2, a force is acting vertically downwards and particle is moving horizontally with velocity v. That means there is no horizontal component of force that can change the velocity. So velocity will remain the same in this case as well. So kinetic energy of this particle will also remain the same. In scenario 3, a force is acting on the particle at certain angle theta with the horizontal. That means this force can be resolved into two components, one horizontal, another vertical. Horizontal component of the force will change the velocity. So kinetic energy of this particle will change. In scenario 4, a particle is dropped from certain height h. Force of gravity on this particle will work vertically downwards and particle will also move downwards. That means force and velocity vectors are in same direction. So kinetic energy of this particle will increase. In scenario 5, a particle is projected vertically upwards. So it is moving upwards. Force of gravity on it will work vertically downwards. So force and velocity vectors are anti-parallel. So kinetic energy of this particle will decrease. Kinetic energy of a system of particles is the sum of the kinetic energy of all its constituent particles. It is given by k is equal to summation of half mi vi square. Kinetic energy k is equal to half mv square. If we differentiate k with respect to time, we get dk by dt is equal to d by dt of half mv square. Half m is constant, so it can be taken out. So right hand side will be 1 by 2m d by dt of v square. D by dt of v square is equal to 2v dv by dt. 2 gets cancelled. So right hand side will be mv dv by dt. dv by dt is acceleration a. So it will be mass into acceleration into velocity. Mass into acceleration is force. So it will be Ft into v, where Ft is resultant tangential force. Suppose resultant force F makes an angle theta with the velocity. So Ft will be equal to F cos theta. So we can put F cos theta here. So dk by dt is equal to F cos theta into v. That is Fv cos theta. We can write Fv cos theta as vector F dot vector v. Vector v can be written as dr by dt, where r is displacement vector. So dk is equal to F dot dr. F dot dr is called the work done by the force F on the particle during a small displacement dr. If we have to calculate the work done for a finite displacement, we need to integrate this. So W is equal to integration of F dot dr. F dot dr is equal to dk. So integration of F dot dr is equal to integration of dk. Integration of F dot dr is equal to W. So W is equal to integration of dk is k2 minus k1. That is change in kinetic energy. So we can conclude that the work done on a particle by the resultant force is equal to the change in the kinetic energy. This is called the work energy theorem. If F1, F2, F3 and so on are individual forces acting on a particle, then the resultant force F is equal to vector sum of individual forces. Then total work done W is equal to integration of F dot dr. In place of f, we can write f1 plus f2 plus f3 plus and so on. Now, this can be split as integration of f1 dot dr plus integration of f2 dot dr plus integration of f3 dot dr plus and so on. This can be written as w1, this can be written as w2, this can be written as w3 plus and so on. So, w is equal to w1 plus w2 plus w3 plus and so on. What it means is work done by the resultant force is equal to the sum of work done by the individual forces. In next video, we will see how to calculate work done in different scenarios. If you have a question, you can ask me on my Discord server. If you have not subscribed my channel yet, please do so.